So this is all about angles of a triangle. And before we get started on that, let's define some terms. First of all, you're probably familiar with a triangle, and it's a figure formed by segments connecting three non-collinear points. Each corner of a triangle is called a vertex, and if we talk about more than one vertex, we call them vertices. Each corner has an angle, and each segment is called a side. Now we can classify triangles by sides. If none of the sides are congruent, we say that it is scalene. If two of the sides are congruent, we say that it's isosceles. And if all three sides are congruent, we say that it's an equilateral triangle. We can also classify triangles by their angles. If all of the angles are less than 90, then we say it is acute. If one of the angles is greater than 90, we say it is obtuse. If one angle is 90, it's a right triangle. And if all of the angles are congruent, we say it's equiangular. Now let's take a look at a theorem. I'm going to create a random triangle here. And I'm going to measure all three angles. Okay, so here is angle ACB, angle BAC, and angle CBA. And I'm going to add up all of those angle measures. So let's get our calculator here. And I'm going to go that angle plus that angle plus our third angle. And you'll notice that they all equal 180 when we add them all up. And that seems to be true no matter how I change the shape of the triangle. So even though the individual angle measures change, their sum is always 180. And that's actually a theorem. The sum of the measures of the angles of a triangle is 180. And it's a pretty cool proof. Let's take a look at it. Let's draw a line that's parallel to the base. Okay? I'll call this angle 1, angle 2, and angle 3. Now since this is parallel to that, then that means that this angle right here, which we'll call angle 4, has to be congruent to angle 1 because they're alternate interiors. And this angle right here, which we'll call angle 5, has to be congruent to angle 2 because they're alternate interiors over here. And so that means that the measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 is going to add up to 180. And then we can do a substitution. Since angle 4 is the same as angle 1, we'll leave angle 3 in there, and angle 5 is the same as angle 2. Their sum equals 180, and that's the proof. Well, from that theorem we can get all kinds of corollaries, and corollaries are just conclusions that follow directly from a theorem. And one of them is if two angles of one triangle are congruent to two angles of another triangle. So if I say that this angle is congruent to that one, and that angle is congruent to that one, since all three of these have to add up to 180, and all three of these have to add up to 180, and these pairs are already taken, then this third angle must be congruent to that third angle. Here's another corollary. Each angle of an equiangular triangle has measure of 60. Since all the angles of an equiangular triangle are all the same measure, then that means that 3x equals 180, so x is 60. Here's another corollary. In a triangle there can be at most one right angle, or one obtuse angle. If I had more than one right angle here, then I would have two angles that added up to 180, and there'd be nothing left over for the third angle. And the same here. If this is an obtuse angle, which means it's greater than 90, say 100, I wouldn't have enough left over for another obtuse angle. We can only have one obtuse angle at a time. And finally, the acute angles of a right triangle are complementary. If that's 90, and angle 1 and angle 2 are in this triangle, then the measure of angle 1 plus the measure of angle 2 plus 90 has to equal 180. And I can subtract 90 from both sides. And I have 9 left over. Well, that's the definition of complementary angles, two angles that add up to 90. Okay, last theorem. The measure of an exterior angle of a triangle equals the sum of the measures of the two remote interior angles. So let's call this angle 1, angle 2, angle 3, and angle 4. Now, exterior means outside, so here's our exterior angle right here, angle 4. And you'll notice that the measure of angle 4 plus the measure of angle 1 has to equal 180 because they're supplementary, right? Well, guess what? The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 also equal 180 because they are the interior angles. And I can now replace angle 1, or I'm sorry, angle 2 and 3 with angle 4. Because the measure of angle 1 is equal to 180 minus the measure of angle 4. And the measure of angle 1 is equal to 180 minus measure angle 2 plus measure of angle 3. So that means that angle 4 and 2 plus 3 have to equal each other. So what's this theorem saying? It's saying that this big exterior angle is equal to the two interior angles that are furthest away from it, the remote interior angles. Let's do a couple of examples. So let's find angle X and angle Y, okay? Well, angle X is going to equal 30 because this line up here is parallel to that and they are alternate interior angles. So they are congruent. That means that this angle right here is going to be 180 minus 50 minus 30 because all three of these angles in this triangle have to add up to 180. And so that's going to give us 100. And that means angle Y is going to be the supplement of 100, so angle Y is equal to 80. Another way to look at that is once I know that angle X is 30, angle Y is an exterior angle of this triangle, so it's going to equal 50 plus 30, which is 80. So you had a couple ways to solve that one. All right, let's look at this one. We have a right triangle in here, and that means we can get angle Y right away because it has to be complementary to 65. So the measure of angle Y is going to be 90 minus 65, which is 25. Okay? And now we can take a look at angle X, and it is an exterior angle of this triangle right here. Since it's the exterior angle of that triangle, that means the measure of angle X is equal to the sum of the remote interior angles, this angle here and that angle there. So it's equal to 65 plus 25, and it is 90.